All right, seventh graders, this is the corrections for lesson 110 in your math. And so I'm only going to be doing the working the problems that were missed the most in the class. And so I will not be working all of them because it would probably just take too long. And so definitely those, I'm trying to get those that were missed at least twice. And I'll rework those so that you can correct that. So we're on problem set 110, page 507. Number 1, use the ratio box to solve this problem. Jason's remote control car traveled 440 feet in 10 seconds. At that rate, how long would it take the car to travel a mile? Okay, so let's just mark this number 1, 440 feet in 10 seconds. And that is equal to, at that rate, how long would it take the car to travel a mile? And so a mile is 5,280 feet. And so just cross multiply here, and that would give you the answer in seconds. So you can either answer in seconds or in minutes. Number 4, baseball. Not seeing a lot of baseball right now. As our president said, it gets kind of old watching a baseball game from 15 years ago. I think he said he turns it off after the first batter. Baseball player's batting average is found by dividing the number of hits by the number of at-bats and writing the result as a decimal number rounded to the nearest thousandths. If Erica had 24 hits and 61 at-bats, what was her batting average? So 24 hits, right, divided by at-bats. So 24 hits divided by 61 at-bats. So just take it out to three decimal places, right? There's thousands. So actually, I said that wrong. I should take it out to 4 decimal places, round it up to 3. Number 5, use 2 unit multipliers to convert 18 square feet to square yards. And so 5, 18 square feet, and we're going to go to square yards. And so I need to do this twice, and so yard over feet times yard over feet, right? And so I have 1 yard is 3 feet, 1 yard is 3 feet. This goes over 1, and then this obviously will cancel because foot times foot is that. And so I have 18 yards squared divided by 9. So number 6, graph the integers greater than a -4. Integers would be the counting numbers. Go back to that lesson a few lessons ago where you had your page 490. The integers would be the counting numbers. Then the whole numbers would be the counting numbers in 0. And then the integers would be the negative numbers as well, right? And so the integers greater than -4, right? So 6, and so the integers greater than -4, so if this is 0, and this is -1, this is -2, -3, -4, this is 1, 2, and so on. So the integers greater than -4, well, if they were be greater than -4, then I would not include that, right? And so just the integers. It would not include anything in between these marks because that would not be an integer. So it would just be like this. Let's go to number 8. And I think I'll just work all of these. So let's put number 8 up here. And use this figure to find the measure of each angle. I think everybody got 8A right, and so let's go on to 8B, which is angle B. Okay, so if I, first of all, let's find So let's just sketch this thing. And so it looks something like this. This is the right angle. And then this is 70. And this is 35. Okay, and so we know that this is 55 because that was our answer. Everybody got that one right. Okay, so how do I find what the angle for what is B? So B is this thing here. Okay, so if we consider this line here, remember that a straight line is 180 degrees. And so if anytime that I draw a straight line and I have an angle that goes into that straight line, then whatever this, let's say this is 60 degrees, then to get this angle here, then since this straight line is 180, then I would take 180 minus 60, and so this would have to be 120. A straight line always adds up to 180, and so if this is my straight line, right, I take 180 minus 55, and minus 5 is 5, 2, and so B is 125 degrees. And then C is going to be, remember that whenever the lines cross, the opposite angles are always identical. So you should be able to get C very easily. And then D, since we know what C is, and all the angles of a triangle add up to 180 degrees, so I take 180 minus 70 minus C to get this. Okay, let's go on to number 12. So, number 12. Compare A squared and A. A squared and A if A is 0.5. So 0.5 times 0.5 squared is what? So 0.5 times 0.5, right, would be 25 with 2 decimal places. This would be 0.25 compared to 0.5. Well, we know what that is. Okay. 16. I'm probably have to do some erasing here. So I'll go up here and start erasing up here. 16. The sale price of $24 was 75% of the regular price. The sale price was how many dollars less than the regular price? So 24 is equal to 0.75 times some number. Okay? And so then X by itself, since it's being multiplied by 0.75, then I need to divide that side by 0.75, right? And so X is equal to 24 divided by 0.75. That is my regular price. Then the question is, how many dollars less than the regular price, right? And so this number here, it's subtracted, I'm sorry, this would be up here, minus 24 to get my answer. Write an equation to solve this problem. 20 is what percent of 200? All right. So 17, 20 is what percent of 200? Divide both sides by 200. Right? And so this will give you a fraction, right? And so take that fraction times 100%. So whatever my fraction is times 100%, and that will give me my percent. Number 18, find the area of the trapezoid. And so what I can do here, this is 18, and so goes something like this. I can split this in two like this, and my numbers are 30 and 10, and my height is 24, right? And so I have two triangles. My base of this triangle is 30, base times height, divided by 2. And then the other triangle would be base of 10 times the height of 24 divided by 2. And then I would add those two numbers up for my answer, area for the whole thing. 21. Multiply and write the product in scientific notation, okay? So, 21, and so I have 1.25 times 10 to the negative third power, and 8 times 10 to the negative fifth power. Okay, so what I do here is I take 1.25 times 8, so 1.25 times 8, which is 10, and then I have 10, and then I add my exponents, and that's a negative 8. However, I'm not done yet, because my understood decimal point is there. I need to move it there, right? And so my final answer would be 1 times 10, and then you figure out what to do with that decimal point. I would need to add 1 to that decimal. I'm sorry, I said that wrong, to that exponent. So I need to move my decimal point 1 back, 1 left, and add 1 to this, negative 8, my exponent. Let's go into 29 and 30. 29 and 30. So 29 is a positive 3 and negative 4 and a negative 6. And then I have a negative 3 and plus a negative 4 minus a negative 6. Okay. So, rewriting this, I have a positive 3 and a positive 24, because when I multiply the 6 times the 4, I get a 24, and I have an even number of negative signs there. And then I have a negative 3. The 4 is negative because I have one negative sign in front of it, and then the 6 is positive because I have an even number of negative signs. And so 24 times 3 would, 24 plus 3 would be my numerator, and then a negative 7 plus 6 would be my denominator. And just reduce that. Let's work on one more here, which would be number 30. Is a negative 5 minus a positive 6 and a negative 2, and then plus negative 2 times negative 3 times a negative 1, negative 3 and a negative 1. Okay, so I have negative 5, and then I have, this is multiplication here, right? So 6 times 2 is a 12. What sign does it get? How many count the number of negative signs? So 1, 2, that's an even number, so this is positive. And then back here is multiplication as well. 2 times 3 is 6, times 1 is a 6. Is it negative or positive? So 1, 2, 3 negative signs, and so that's going to be negative, all right? And so I have a negative 11 and a positive 12, and I'll let you take it from there. And that's it for this lesson, and I will also do a lesson on for correcting lesson 111.